Good afternoon, everybody, and I will start my next sessions on a topic related to cloud computing. Today's class will be covering a very important technology which is actually shaping the entire prospectus of cloud computing, and it is called MapReduce algorithm or MapReduce framework. It is a model for distributed processing. Today we know that due to the networks such as internet and all, data and users are scattered across the network. For that reason, it is impossible to centralize everything in one location and process data. It has to be in a different location. Such an application which needs to collect data from different locations and process them simultaneously is called actually distributed processing. So the traditional computing, we did not have enough and powerful frameworks to process such kind of a data. And as a solution, we have found out one, and that is called MapReduce algorithm. So what is the motivation? The internet today and the web and cloud computing pose a new challenge for data management. The traditional methods of data management cannot scale up to the massive data flows generated by the web. See, the kind of data that is generated on internet activities such as Facebook and Google is very immense, and ordinary people like us cannot even imagine that. So the traditional approach of databases, file systems are not sufficient enough to actually manage this data. So MapReduce is a new approach for managing such web scale data flows. So the data that is flown, created, and actually in the internet can only be managed by this one. So that is the idea behind the MapReduce. So what's the learning objective? There is a very simple learning objective for us today. After the successful completion of this session, a learner will be able to understand the need for a new approach to process web scale data. So the web scale data that we have been actually generating today is something which was unseen in the past. So a user will understand that the traditional and the old methods are not sufficient enough. Then once that is realized, then we will also be shown the concept and practice of MapReduce framework. The agenda is very simple. Challenges of web scale processing that I already told you. The cloud computing giants like Facebook and Google and even Amazon and all produce terabytes of data every day. So that's a big challenge. So MapReduce is a solution. It's a kind of a distributed system which will help you to connect data sources and use different computers to solve your data challenge problems. Then also we will list different features of MapReduce. Then the first question comes, what is MapReduce? See, MapReduce is a software framework introduced by Google in 2004. As we all know, Internet started to appear into the public in the 2000 onwards. So Google was the first company which made a very good name in Internet. Their search engine today is such an utility that everybody in the community, in the society uses that. But when Google started operating its search engine, they tried to use many of the traditional systems, and they all had limitations. For example, updating a data into an index file or searching a particular web page. They were very slow. So in order to overcome this unique challenge, they designed their own framework, which is called which is called MapReduce. So this MapReduce algorithm supports distributed computing. So distributed computing is a mechanism where different computers store different data, and different locations are use computers, and they process data simultaneously and produce the data. The second quality of this MapReduce is it can act on large set of data. For example, in a traditional, a bank might be using Oracle database which may have about 20,000 or 30 lakhs users. But on cloud computing platform, it runs into millions of users. But MapReduce can take that one. The inspiration. Why and how did we actually create this MapReduce? The framework is inspired by map and reduce functions commonly used in functional programming. Anybody with a background in computer science knows that there are different approaches for programming. So one is called actually procedural programming, like the C programming language or COBOL, where actually you write a procedure and a combination of that procedure will constitute a program, and that will do your job. For example, you will write one procedure for payroll, one procedure for student attendance, and so on and so forth. Well, procedural programs actually solve many of the daily problems. It is not possible for certain applications. So for such actually, we have developed what is known as functional programming. So the normal procedural programming actually take as a input some numbers or some data. whereas functional programmings are capable of taking functions as their input. So the MapReduce algorithm is essentially based on this functional programming concept, where function can be given as an input. And MapReduce is written using certain very well-known programs languages like C++ and Perl, Python, and so on and so forth. So the inspiration for MapReduce comes from a functional programming. So now let me look into the details of the MapReduce algorithm. MapReduce is a framework for processing highly distributable problems across the huge data sets. Highly distributable is something like this. See, now assume that there is a function or there is a program that you have to run, for which actually data is stored in different machines across the world. For a simple example, look at this Google search engine. So Google or any cloud computing company will actually have built an infrastructure called data centers, and these data centers are actually globally distributed. For example, Google will have a couple of data centers in America, few in Europe, some in China, some in Japan. And kind of data that's stored, they actually distributed over all these data centers. So in order to collect such data from different data centers and process them, MapReduce is used. And secondly, the beauty of this MapReduce algorithm is it doesn't depend on a traditional computing like on a single machine or a single processor. It can use lot many computers spread across different locations. So MapReduce is a highly distributable. That means the function can be distributed. It can collect lot of data from different locations, and it can operate on a couple of machines. So when you distribute a work to a couple of machines, these machines can be called clusters if all nodes are same in the hardware. For example, if there is a MapReduce program which is being run in my college and all the resources which are needed are given from a single server, then such a thing is called a cluster. So cluster is a group of resources on a single hardware available for MapReduce. Many times this may not be possible. Some machines may be given in my college, some in another university, or some in another town. If that is the thing, then that is called a grid. So a distributed work from a MapReduce can work on a single hardware, in which case it is called cluster, and it can work on different hardwares located at different locations, and that is called grid. So what does actually MapReduce during processing? Computational processing can occur on data stored in either file system or database. And we all know actually in the traditional programming languages, C can handle certain kind of data. For example, it can create a file and operate on it. But it cannot actually work on databases. Similarly, Oracle can act only on databases, nothing else. Similarly, Excel sheet can work only on spreadsheets. But when we are using MapReduce, the processing is a different kind of a liberation. What it actually means is you can use a file system in which is unstructured data. An example for unstructured data is like a notepad data or a Facebook update. Somebody might open Facebook and post a comment which is a text, or somebody can include a smiley on that, or somebody can upload an image on that, or somebody can upload a video on that. All this actually is called unstructured data. And the traditional kind of a databases like Oracle, which have a student database or employee database or a bank accounts database, is called a traditional structured database. So MapReduce can actually process two kinds of data: file system which is unstructured and database which is structured. How does MapReduce work? Now that I told you what it can do, I will tell you how it will do. See, whenever there is a big task which is to be done by a couple of machines, the MapReduce will start with the first step called map step. The master node takes input. That means now you are contacting a computer to do your work. The machine that you contact is called a master, and it's called a master node because that is the terminology used. The master node will take the input and partition that task into different parts, and these parts are distributed to other set of machines, and these machines are called worker nodes. So master node is the machine for which you submit your job. The master will split that work into many partitions and give it to different nodes, and these nodes are called worker nodes. There is an example. For example, when you see a honey web, actually there are even ant group. There are actually queen bees and also the worker bees. Similarly, now these worker nodes will take that job. The worker node may do this again. Assume that there is a very big task which is given by a master to a worker node. And if the worker node thinks that the this job is still big, that again can find out subordinate nodes which act as a worker node to that worker node. Okay, and the worker node processes the smaller problems and passes back to the master node. So you start with a job, give it to a master node who will distribute job into multiple worker nodes, which in turn, depending on the intensity and the spread of the job, can be distributed. So once this is distributed, and once this worker nodes start doing the work, at the end of the work, actually they will pass back the results back to their worker nodes or whatever the master node, and they in turn will return it to the ultimate worker node. So the reduction step is a process where actually once the work is completed by the worker node, they will actually collect all the data given by those machines and send it back to the main master node, who will actually compile it into one result and give it to the user. A simple example is like this. So suppose there is a user who is actually using Google search engine. So he will go to Google search engine and type a keyword. The moment keyword is typed, what Google does at background is actually it will take that keyword and it will ask one master node to take that job. The master node will actually convert that into smaller sections and pass it on to different data centers and different machines in those data centers. These will simultaneously process your data and send back to the master node. The master node will compile and give it on a sheet on your web page. So whenever you search something on this, Google actually gives you a first page result, and it also says it took some 91.91 seconds. What it actually means is, you give me a job, I sent it to many of my machines, they return me the answer, and it took about 9.91 seconds to do this. So each of the pages which you see after seeing the first page might have come from different worker nodes. So this is exactly happens. So reduction or the reduce step is one in which actually you get results back from your worker nodes. So what are the practical points about this? I will tell you. So MapReduce will allow you to do certain things. For example, it allows you distributed processing for map and detection operations. Provided such each operation is independent, all maps can be performed in parallel. Suppose you have a job which can be split into 1,000 parts, and all these 1,000 parts can be done independently. Then there is a way in which actually MapReduce can do it very fast. However, in practice, not all jobs can be split that way. And even if you split, there are other challenges. For example, even if there are two split jobs running on a worker node, but if they use the same data, then that is also limits the speed of that function. Secondly, a set of reducers can perform the reduction phase simultaneously. Assume that you have sent your job to worker nodes, and they can actually come together, assuming that everybody is asked to do a search on a same set of results, and actually combine together as one result and give it back. What it means is the reducers or the worker nodes can compile the results into one result and send it back to your master. So what are the practical uses of this? A large server farm can use MapReduce to sort out data which runs into some petabyte in only few hours. So petabyte means it's huge database. For example, astronomical thing, moon or studying Mars and all, you get a lot of data from your InSat kind of a satellites and all. So that kind of a data can be processed within few hours if you are using a MapReduce algorithm, because a big data set and a big function is actually split into a couple of machines and data centers, and that will actually solve the problem. See, for example, by 2010, Google was processing 20 terabyte of data every day. This is a very huge data. And Facebook was processing about 15 petabyte. So that is much bigger. So this kind of a task can only be done by MapReduce algorithms. The parallel feature of this MapReduce can actually help you in another way. For example, since to do a work, you don't have to worry, because if one of the machine goes down, then you can always ask another machine to do that job. So in a traditional company, one machine, and if the hardware fails, that's the end of the story. Then again you reset the system again and run. But in MapReduce, that is not the case. Even hundreds of millions of users, when machines are working, if one or two machines go wrong, still that job can be redistributed to another machine and can take. So the first advantage of MapReduce is it can parallelize your activities. Secondly, it can have a redundancy to you. So a failure is not a serious thing in MapReduce. And although they are not going to be very fast, the simple reason that so many thousands of processes are working makes the whole job much faster for you. Second, MapReduce achieves a kind of reliability because it passes out a number of operations in and out of the data centers. So periodically, these worker machines can tell you the update. For example, if there's a huge task which takes hours or even days for the processing, the worker node for whom you have assigned the job will keep you updating all the things all the time. So that means at least you know the progress that is happening for all of your activities. Okay, so then the question comes, what are the different uses for MapReduce? MapReduce is very useful in wide range of application. I told you big data is a big challenge today. It's an opportunity also. So MapReduce can be used in distributed pattern based searchings. For example, if you are searching for a picture, or if you think that you are searching for a picture of a celebrity or a terrorist in a big database like internet and all, MapReduce will help you a lot. Similarly, in document clustering. Document clustering is a technology where actually you group together different documents for certain reasons like research, periodicals and all. What are the practical examples? For example, at Google, MapReduce was used to completely regenerate their Google index. See, what Google does is actually it has something called a crawler. Crawler will visit every web page and collect the content. This content goes back to the database of Google. And when it goes to Google database, they actually want to organize that data. So for that, they actually build an index. Since the global data is too big, they use MapReduce algorithm to sort that data, organize that data, index that data, and so on and so forth. So what's the conclusion? So today we have a new challenge, the challenge of internet, web and other things. So what is the consequence? Consequence is every user actually operates on data on the internet, and every time he does there is a transaction, and every time there is a transaction there is a data generated. So this is a huge, massive amount of data flow which has to be managed. The traditional computing, database technologies will not help you. So in order to overcome that, the technology companies or technology organizations have come out with a new algorithm, a new framework called MapReduce. This serves an important data stream created by the internet. It is behind the success of many companies like Google and other like Facebook and all. So what are the references? For this presentation, I have already used the MapReduce article from Wikipedia and also MapReduce tutorial by Mr. Petro Mirchanti. So thank you. Thank you, Sridhar. Sridhar, I am done.